So, good morning, everyone. Today we are going to discuss about circular plane problem. Okay, here the problem statement is given: a circular lamina of 50 diameter rests on HP such that one of its diameter is inclined 30 degree to VP and 45 degree to HP. Draw its top and front view in this position. Okay, a circular lamina of 50 diameter rests on HP. With this, we can draw a initial position, that is, take a circle with visible line, draw a circle of 50 diameter. So my resolution is high, so I am selecting 1 thick. In your case, just select visible line and draw a circle of 50 diameter. Okay. So since two angles are given, so a circular lamina 50 diameter rests on HP such that one of the diameter is inclined 30 degree to VP and 45 degree to HP. When two angles are given, better you divide the circle into 8 equal number of parts. For that, first you draw a radius line with the help of normal line. The circular plane, when you see from the top view, it look only boundaries are visible, only circular boundaries are visible. Whatever you draw inside, that is just for our construction purpose. To locate the profile or to draw the profile. So now I want to divide into 8 equal parts. For that, first you take a draw a radius line from the center point. You draw the radius line, then you select this line. Use pattern option here, circular pattern. Yeah, below trim option, you have pattern option in that circular pattern. Okay, so now I want number of count is 8. I want 8 division, give 8 count, and angle is total angle is 360. Give 360. Okay, and then click for the center point of a circular array. Once you give number of count and angle, click the center point of the circle. Then finish. It will take 8 equal division. That's it. I'll repeat this. Okay. See here, first draw the radius line, then select that radius line, then use circular array. Okay, give number of count 8 depending upon number of division. Here I want 8 division and angle, total angle of the circle 360. In 360 angle I want 8 division and click the center of the circle and then finish. We'll get 8 division. Then use smart dimension and measure the given dimension like this 50 diameter and give the naming. Say this is A, use small letter A, B, C, D, E, F, G, and H. Then use the projection line. A, draw projection line up to XY line. B and H will go along same line, just take it from H. Similarly, C and G will go along same line, take it from G. D and F, take it from F. Similarly, from E, you take it from E. Then you draw the front view. Front view is a straight line joining from end of this projection to end of this projection. So as I told you, my system resolution is high, so that I will select thickness 1. Okay. When it is resting on HP, in VP it is completely flat. It is the front view is lies on XY line in VP. So the distance 0 from HP, that 0 distance appear in VP. So if you draw on XY line in VP, that indicates this HP resting. Now do mark the points. So this is A dash point, this is B dash of H dash. Similarly, this one is C dash of G dash. This one is D dash of F dash, and this one is E dash. Okay. So once you complete, so the first position is over. Circular lamina of 50 diameter rest on HP. This much is over, such that one of the diameter is inclined to 30 degree to VP and 45 degree to HP. Since the primary reference plane is HP here, on HP you can see the circular plane, circular profile. That's why primary reference plane is HP. You have to give the first inclination to HP only. For that reason, you have to give the first inclination to HP only. Okay. So HP inclination is 45 degree to HP. So diameter is inclined. That means EA is the diameter. You consider EA is the diameter. Okay, EA here, what is EA point? E to A. It is a straight line, parallel line. If you incline this line, that indicates along with that diameter also will incline. So select move option, move from left E corner and place it on this. Before moving, so you want to locate intermediate point D of F, C of G, B of H. In order to have that, hold the control button and select these intermediate projection lines also. Then you can move this like this. Move on, place it like this. Then rotate. What is the angle? HP angle is 45 degree. 45 degree. Now copy mode should be off. 45 degree. Press enter button. Okay. So click above the XY line. Now extended lines you trim. Better you trim this extended line and measure the angle. What is the angle? 45. Okay. After that, what you have to do? Draw the projection. Draw the projection. Normal line. So here along the A line, what are the lines will go along the A line? You have E point and A point. E and A is along the A line. Okay, AE will go along this. So E and A mark up to that only. Don't create unnecessary extra line. Then mark here only. This is A and this is E. Similarly, along this line, B and D will go along this line. From end of this line, draw this line. B and B line 60 angle 90 and D line will go along. Then trim the unwanted line. So mark the point. What is this point? This point is B and this point is D. Similarly, along this line, C point will go on. So mark C point up to here. Then trim the unwanted line. Mark C here. Then B and H. B and H will meet here. F will meet here. Fix the angle 0 and drag up to this line. Enter. Drag up to here H point. F point will be here. Mark the F point and H point. Similarly, G point. So once you mark all the point A, B, C, D, E, F, G, H, okay. Now you have to draw the profile. Okay. So when the circular lamina inclined to one plane, primary reference plane, when you incline the circular lamina to one plane, it look like an ellipse. Okay, perfect ellipse. When it look like a perfect ellipse, here you see GC is one of the diameter and EA is the diameter perpendicular to GC. These are the two diameter which is perpendicular to each other. When you consider these two diameter, here also you see GC and EA remains perpendicular. When these two diameter remains perpendicular, it will be a perfect ellipse. For that you can use perfect ellipse option. For that, what I will do, I will trim one end here so that I can easily get the midpoint of the ellipse. Use ellipse by center point. Click the midpoint of the ellipse. Use visible line here. So give the major axis distance. Up to G point is the major axis and up to A point is the minor axis. Like this. You can directly draw the ellipse. Okay. When it is inclined to single plane, only primary reference plane, in second position top view, you can directly draw the ellipse. Okay, what you have to do in next position? Next position you have to give VP inclination. So VP inclination is also with respect to diameter. Diameter is inclined to VP at 30 degree. For that what I will do? Select the line, normal line, and better I take a parallel line, and from here I will take 30-degree line. Fix the angle 30 and drag the line. Minus 30, sorry, minus 30, drag the line down. Okay, so now what you have to do here, the diameter inclination is given to VP. So what is the length of the diameter in first position? You can see length of the diameter in first position is 50. So what is the length of the diameter in second position? Length of the diameter in second position is distance between this E projection and A projection. This will give diameter length in second position. When you see this, the diameter is reduced. When you have true length and apparent length case, then you need to find apparent angle of inclination, because VP angle is given to true length of the diameter. Diameter is inclined to VP at 30 degree. That indicates angle is given to true length. But you have to place second position top view in the third position. For that you need to find what is apparent length inclination. How to find? Take a arc by center point. Before arc by center point, click any point along the 30-degree line, fix the radius 50 mm, press enter and draw the arc up to 30-degree line. Then draw the locus. Then you need to draw the second arc, which is 35.6 line 66. So move the cursor on the arc center will highlight. Okay, so now say take the second arc dimension 35.66, press enter and draw the second arc from here to locus. Okay, now join this line. So second arc intersecting at locus to arc center line you need to join. Then measure the angle. So angle given, true length angle is 30. Okay, and apparent length angle what you found out is 45. Okay, so now what you have to do, once you find out the angle, the true length is this one, apparent length is from here to here. So you need to place second position top view on the apparent angle line. So select this. Now, so when you move, what happen you see? I want to place this E point. So when you move, you're not able to locate all the points here. Okay, here you see. For that, in order to locate all the points A, B, C, D, E, F, G, H, what you have to do, before moving, you draw one line here. A to, take a normal line and draw A to E, one line. So when you are moving, AE line also move, so that you will get A point reference and E point reference. Similarly, GC line also you draw. Then you will get G and C reference. Similarly, here also you draw FH reference. Yes, or DF reference. You better zoom this and draw FH reference. You're not getting here end point, from end point to this. Okay, similarly you ended this line here, from here to here you draw. So I drawn GC line so that G and C reference I will get, and EA line so that E and A reference I will get, DB line and FH line to get those reference. Then fit. Now you move. Once you draw those line, now you move the circle so that every point you can locate now. Pick from E point. The copy mode should be on. Now move the cursor on the arc. Arc center will highlight. Now place it on the arc center. Now you rotate. EA line should be matched with this 41-degree line or the end of the arc intersecting the locus like this. Okay, once you draw that, then you draw the projection line. See, along XY line, only E point is coming along XY line. So, you take E point up to XY line. Okay, E point, this one. Similarly, along this line, DF line will come. Along this line, DF line will come. Where is D? So, here is the D line. D and F. Here is F line. DF line will come. Only those two lines. Then trim the unwanted line. Similarly, along this CG will get mark C and G up to this line. C and G. Then trim the unwanted. Similarly, here BH. BH will get end of this line is B and end of this line is H. PH will get up to this line. Then you only left with A. A point will come up to here. Then trim. Now mark the point, which is A, the end projection what you got, that is A. So now we have to see where is the B. Once you get AB, then you can AB, this will be C. So you know the path direction C, and this will be D, D dash, and this will be E dash, F dash, like that, E, F, continuously it will go like this. Then G dash, then H dash. See, when you are joining the line like this, say this F point meet here, it should be end here only. Don't carry the extra projection upward or forward. So then it will be easy to join. Now we have to join A, B, C, D, E, F, G, H. Now we have scattered points of the circle. Okay, so now it is inclined to both HP and VP. When it is only inclined to HP, so you can draw the perfect ellipse. You can use ellipse command because GC and AE are the two diameter perpendicular to each other. These two diameter remains perpendicular to each other. When it is remains perpendicular to each other, it will directly you can use ellipse. Here you can see what about GC and EA. So where is GC? GC line is this one. EA line is this one. Now EA line is not perpendicular to GC. When EA line is not perpendicular to GC, we cannot use directly ellipse. Instead of that, use arc by 3 point. Use the visible line, arc by 3 point. Okay, use the visible line, and now you can join 3 point arc. First point, second point, this is third point. Similarly, arc by 3 point. So the end of this line is first point, end of this D is second point, E is third point. Similarly, you can use E, F, G. Similarly, G, H, A. Like this you can use. So if it is not 100% perfect also, it's okay. You can use arc by 3 point to draw this. You cannot directly use the ellipse option because the two diameter which is perpendicular to each other in the initial stage, it not remains perpendicular here. That's why you cannot use ellipse directly. Okay. Thank you.